Hey everyone, and welcome to Trending Tidbits. Today, we're going to be getting up to speed on something pretty cool, the mid-cingulate cortex, or MCC for short. So think of this as like your express lane to figuring out what this brain region does and why it even matters, all based on some really cool research papers and a great literature review we found.
Yeah, what's really got me interested is how much research there is on the MCC now, especially in rodents. It seems like scientists are finally realizing how important this area is.
Yeah, it's always exciting when a part of the brain gets its moment in the spotlight, right? So to get us started, where is this? Where is the MCC in the brain?
So picture this. You've got your corpus callosum. That's the bridge connecting the two halves of your brain. Well, the MCC sits right above that, right in the middle, almost like a central command center for the brain, connected to areas that process emotions, help you make decisions, even coordinate movements.
It really does sound like a multitasker. And I've heard that it's not just one big blob, it's divided into sections, right?
Exactly. We've got the anterior MCC, or aMCC for short, and its partner in the back, the posterior MCC, or PMCC. And they're different in terms of how they're structured and what they do.
Okay, so two parts of the brain, each with their own personality, I guess you could say. What can you tell us about what these different parts of the MCC are actually responsible for?
Well, the research suggests that the MCC as a whole plays a role in a lot of different things, a surprising amount of things, actually. Take cognitive control, for instance. The aMCC seems to be really active there. It helps us stay focused and make decisions even when there are distractions.
You mean like when I'm trying to finish writing this script
Ah.
and my phone keeps buzzing with notifications? Is that my aMCC stepping in to keep me on track?
You got it. And that's just one example. One study actually found that if the aMCC is damaged, people have a harder time recognizing facial expressions, like the ones for fear, disgust, and anger.
Wow, that's a really powerful example of how important this one area is.
Mm.
Are there other findings like that?
Oh, definitely. There's also a strong connection between the MCC and regulating our emotions, especially negative emotions. It seems to help us make sense of those feelings and manage them, which is key for navigating our everyday lives, right?
Yeah, for sure. So the next time I'm feeling stressed, I can thank my MCC for helping me process those feelings. What else does the MCC do?
Well, believe it or not, pain processing is another area where the MCC comes into play. I know it might sound unexpected, but pain can trigger really strong emotions. So it makes sense that an area involved in regulating those emotions would be linked to how we process pain as well.
So it's like the MCC is the brain's bodyguard, helping us deal with all the tough stuff. Is there anything that this region doesn't do?
Well, I wouldn't say it does everything, but it's definitely involved in a lot more than we initially thought, along with pain and emotions. The MCC is also involved in motor control. It coordinates our movements to make sure they're smooth and precise.
So it's working with the motor cortex, making sure our movements are more than just robotic.
Exactly, adding that finesse to our movements. And on top of that, the MCC is also important for putting together internal and external information or stimuli. So basically helping us make sense of the world around us by combining information from our senses with what's going on inside of us, like our own
Sure.
thoughts and feelings.
Okay, so we've got cognitive control, emotional regulation, pain processing,
Mm,
movement coordination,
right.
and taking information from inside and out. It really does sound like a central command center.
It does. And that's why it's such a popular topic for research. Because figuring out exactly how the MCC works could change everything, from treating mental health conditions to understanding how we learn and interact with the world.
It really seems like we're just beginning to scratch the surface of what the MCC is capable of. Speaking of scratching the surface, let's talk about something that's been trending lately in wellness,
Mm.
mindfulness and meditation. Because our sources mention that these things are connected to the MCC.
Yeah, and what's really interesting is that the research seems to point to the aMCC, the anterior part, as being the most affected by these practices.
So all those mindfulness apps I've been seeing could actually be changing my aMCC. That's wild. Why do you think that is?
Well, think about what meditation involves. Paying attention to the present moment, noticing your thoughts and feelings without judgment. All of those things are connected to the aMCC's role in regulating attention and emotions.
That makes sense.
Yeah.
Did the researchers actually find any physical changes in the aMCC after people meditated?
Oh, there's some really fascinating evidence. For example, one study showed that meditation can actually make the gray matter more dense in certain brain areas, including, you guessed it, the aMCC. And another study found that people who meditate a lot show different activity patterns in the default mode network. That's the network that's connected to our mind wandering, compared to people who don't meditate.
So meditation could be physically changing our brains. and influencing how our minds work, even when we're not actively meditating. That's amazing.
It is. And here's another thing I found really interesting. The research seems to suggest that the aMCC could be connected to tenacity, that ability to stick with things even when they get hard.
Like when I'm working on a tough project and I want to just give up, but I push through. Is that my aMCC?
It could be. The aMCC seems to be involved in how we weigh the costs and benefits of doing something, which can influence how persistent we are. And this connects back to its role in motivating us and goal-directed behavior.
Okay, so it's like I'm seeing a pattern here. The aMCC is involved in handling tough things, regulating negative emotions, and helping us stay motivated. It's like the ultimate mental resilience toolkit.
That's a great way to put it. And the implications of this research could be huge. If we can figure out exactly how the aMCC works, it could help us understand and maybe even address things like apathy and conditions like depression and dementia, or even figure out how to boost motivation for things like healthy eating or
Man,
exercise.
it's blowing my mind. It's amazing that this one tiny part of our brain can have such a big impact on our lives.
It really is. And there's so much more to learn about the aMCC. For example, researchers are looking into how the aMCC might play a role in healthy aging. Imagine if we could use this to help people stay sharp and mentally healthy as they get older.
Now, that would be a game changer. It sounds like we've learned a lot about the aMCC. But before we move on, could you remind me about the posterior MCC, the PMCC? What's that one up to?
You're right, we haven't talked about that one as much. But the PMCC is just as important as the aMCC. Even though it's been studied less, it plays a key role in how we process spatial information and navigate our environment.
So it's like when I'm trying to find my way through a crowded mall, is my PMCC acting as my internal GPS?
You could say that. It's helping you create a mental map of the space, remember landmarks, and plan your route.
Oh man, I bet taxi drivers have superpowered PMCCs. What about meditation? Does that affect the PMCC?
While most of the research on meditation is focused on the aMCC, there is some evidence that the PMCC might be involved as well. One study found that people who've been meditating for a long time have different functional connectivity between a part of the brainstem called the pons and the PMCC compared to people who don't meditate.
Interesting. So meditation could be influencing how the PMCC connects to other parts of the brain.
Exactly. But we need more research to figure out what that really means.
Well, it sounds like both the aMCC and the PMCC are essential. They both have their own strengths, and they work together to help us figure out the world around us.
And even the world inside of us.
Absolutely. And they're always working with other areas of the brain to make sure everything is running smoothly.
This really makes you appreciate how complex the brain is and how much is going on all the time.
It does. And the more we learn about these processes, the more we understand ourselves and the incredible potential we all have. You know, speaking of teamwork in the brain, there's this really fascinating finding about a mirror circuit that involves the aMCC and another area called the insula, a mirror circuit. What is that?
It's not science fiction, but it's pretty amazing. Basically, this circuit becomes active both when we do something and when we see someone else do the same thing.
So like our brains are mirroring the actions we see.
Exactly. And research suggests that the aMCC and the insula are really important for this.
Okay, let me get this straight. If I reach for my coffee cup, my aMCC and insula would light up. But if I watch you reach for your coffee, the same thing happens in my brain.
You got it. This mirroring is thought to be really important for social learning and empathy. It's as if by simulating other people's actions in our own brains, we can better understand what they're doing and why.
That's so cool. Is this why we cringe when we see someone trip? Or why we feel happy when someone gets good news? Are our aMCCs and insulas firing in empathy?
That's a great connection to make. While it's not the whole story, the mirror circuit likely contributes to these responses. It's fascinating to think that this small part of our brain could be so important for how we connect with other people.
It really shows how much is going on under the surface.
Yeah.
How even small interactions involve a lot of complex activity in the brain.
For sure. And that brings us to another interesting thing about the aMCC. Its role in how we experience thirst and how we feel satisfied after drinking.
Wait, thirst and feeling full, isn't that the hypothalamus's job?
Yeah, you're right. The hypothalamus is the main regulator there. But research has shown that the aMCC and the right posterior insula actually keep track of how our brains value something like water as we drink it.
Okay, so as I'm drinking water, my aMEC is figuring out how rewarding each sip is.
Exactly. It's like the aMCC is watching our internal state and adjusting how much we value something based on how much we need it right then.
So when you're really thirsty, that first sip of water is amazing. But as you drink more, it becomes less and less exciting.
Exactly. It shows how the aMCC helps our brains constantly balance our internal needs with the outside world. And this helps us make choices that keep us balanced.
It's like the aMCC is a conductor in the brain's orchestra, keeping all the different functions in sync.
I love that analogy. And we're still learning so much about what this conductor can do.
This is really making me realize how much we take our brains for granted.
It's true. They're always working behind the scenes, taking in information, making decisions, coordinating actions. The more we learn about these things, the more we can appreciate how complex and powerful our brains are.
I know, right? Well, my aMCC is definitely working hard today with all this new information.
Mine too. But that's what Trending Tidbits is all about. Breaking down complex research into something we can all understand. No brain overload required.
Haha. Yeah, no brain overload here. Speaking of absorbing information, maybe we should do a quick recap just to make sure we're all on the same page. What are the main things we've learned about the MCC?
Let's do a quick review.
Okay, so we talked about how the MCC is a really important part of the brain. It's involved in so many functions: cognitive control, regulating emotions, processing pain, coordinating movements, and integrating information from the world around us and our own bodies. And remember how it's got two main sections, the aMCC and the pMCC, each with its own special abilities.
Yep. And we also talked about how mindfulness and meditation can have an effect on the aMCC, potentially making it stronger so it can help us regulate our emotions, focus our attention, and even keep going when things get tough.
Right. And we can't forget that mirror circuit, with the aMCC and insula working together to help us connect with other people and understand their actions and intentions.
That's right. And we also touched on the pMCC's role in spatial awareness, like how we navigate our surroundings, and how meditation might be changing its connections with other parts of the brain.
Wow, it's remarkable how much this one area of the brain does.
It is, and we're just getting started. Speaking of new discoveries, our sources also mention some really exciting possibilities for future research related to the aMCC.
What kind of thing?
Well, one big area of interest is how a deeper understanding of the aMCC could lead to new treatments for mental health conditions.
Oh, wow. Like what specifically?
Researchers are looking into how we could target the aMCC to help with things like depression, anxiety, dementia, and even chronic pain.
That would be incredible. To be able to use what we know about the aMCC to help people and improve their lives.
The potential is huge, and there's also a lot of interest in figuring out how the aMCC helps us age gracefully.
So maybe using this knowledge to help people stay sharp and mentally healthy as they get older.
That's the idea. The fact that the aMCC is involved in attention, emotional regulation, and tenacity makes it a really promising area to study when it comes to healthy aging.
This is all so promising. It feels like we're on the edge of some major breakthroughs in brain science.
It's definitely an exciting time to be studying the brain, and who knows what other amazing things we'll find out as we keep digging deeper into the aMCC.
I can't wait. But for now, let's go back to those sources and explore another really interesting part of the aMCC, its role in handling information from both inside and outside of us.
Yes. This is crucial to understanding how the aMCC helps us navigate our everyday experiences.
So how does it work? What exactly is the aMCC doing with all this information?
Remember, we talked about the aMCC being this master integrator? Well, it's really good at combining information from our senses, our bodies, and our thoughts to give us a complete picture of what's going on both inside and outside of us.
So it's like creating a constant status update of our internal and external worlds.
That's a great way to put it. It takes in everything, what we see, what we hear, what we feel, along with our bodily sensations and our emotions, and then puts it all together.
And why is this so important?
Well, think about it. We're bombarded with information all the time from our environment. And at the same time, we have our own thoughts and feelings and bodily sensations. If we don't have a way to put all of this together, we'd be completely overwhelmed and wouldn't be able to function.
It's like the aMCC is the air traffic controller of the brain, making sure all the different streams of information don't crash into each other.
Exactly. And this is all connected to something called predictive coding.
Predictive coding. I think I've heard that term before.
Sure.
But can you explain it?
Sure. It's basically a theory about how our brains understand the world. The idea is that our brains are constantly making predictions about what's going to happen next, based on what we've experienced in the past and what's happening right now.
So our brains are always trying to guess what's going to happen.
Exactly. And then those predictions are compared to what actually happens, to the information we get from our senses.
So what happens when our prediction is right?
Well, when the prediction matches what we experience, our brains can relax a little. They don't have to work as hard. It's energy efficient.
And what if our prediction is wrong?
That's when things get interesting. When our prediction doesn't match reality, it creates something called an error signal.
An error signal. Is that like our brain saying, oh, something isn't right here?
You could say that. It's basically a signal that something unexpected has happened, and our brains seem to pay attention and update their model of the world.
Okay, so I see how this is connected to the aMCC. Is the aMCC creating these predictions? Or is it detecting the error signals?
That's a good question. It looks like the aMCC is involved in both. It helps generate those predictions, and it also picks up on those errors when our predictions are off.
So it's like a mental detective,
Mm.
comparing our expectations to what's actually happening and telling us when something doesn't add up.
I like that. That's a great way to think about it. And this is so important for learning, for adapting to new situations, and for making decisions.
So next time I'm surprised by something, I can thank my aMCC for being on the case.
Exactly. It's always working hard to help you make sense of the world.
While this talk about predictions and error signals has got me thinking about decision-making, we talked about that earlier. Can we go to that a little more?
Absolutely. Decision-making is complex. It involves a lot of different parts of the brain, but the aMCC seems to play an important role in figuring out the possible outcomes of different choices.
So when I have to make a decision, my aMCC is busy weighing the pros and cons of each option.
Exactly. It helps you think about the rewards and the costs of each choice. And it takes into account your goals, your motivations, and even your emotional state.
So if I'm feeling anxious, that could actually affect the decisions I make.
Absolutely. Our emotions have a huge impact on the choices we make, and the aMCC seems to be a key player in bringing those emotions into the decision-making process.
That makes sense. I guess it explains why sometimes we make decisions that we regret later.
That's a good point. It really shows how important it is to be aware of how we're feeling when we make decisions, especially big ones.
So the aMCC is like this wise advisor,
Yeah.
helping us make good decisions. But sometimes our emotions get in the way.
That's a great way to put it. It shows the back and forth between our rational and emotional minds.
This is all so fascinating. But I have to admit my aMCC is getting tired. We've talked about a lot today. Integrating information, predictions, error signals, decision-making. It's a lot to process.
Me too. It's incredible to think about all of this happening in this one little part of our brains.
And we're only scratching the surface. Our sources talk about all these other things the aMCC might be involved in, like social cognition, self-awareness, and even moral reasoning.
It seems like the aMCC is involved in so many things that make us human.
It's a true multitasker. Well, I think it's safe to say that the aMCC is a superstar in the world of brain science, and we're just getting started.
I agree.
So what's next? What other exciting things about the aMCC are we going to talk about?
Let's take a look at the research on the aMCC's role in processing social information. That's an area where scientists are making some really interesting discoveries.
Okay, let's do it. I want to learn how the aMCC helps us navigate the world of human interaction.
It seems like the aMCC might be involved in helping us pick up on social cues, things like facial expressions, body language, even tone of voice.
So it's like the aMCC is helping us figure out all those little signals people give off when they're interacting with each other.
That's the idea. It's helping us understand other people's emotions, what they're thinking, even how trustworthy they seem. Being able to read those cues is really important for social situations and for forming relationships.
This makes me think about people who have trouble reading those cues, like people on the autism spectrum. Could there be a connection to the aMCC?
That's a really good question, and it's something that researchers are looking into. Some studies have shown that there could be differences in how the aMCC works in people with autism, or in how it connects to other parts of the brain. And these differences might contribute to those social challenges.
It's incredible how one area of the brain can be involved in so many different parts of our lives.
It really is, and the aMCC's role in social stuff doesn't stop there. Research also suggests that it's involved in something called theory of mind.
Theory of mind, I've heard that before. Can you remind me what that is?
So theory of mind is the ability to understand that other people have their own thoughts, beliefs, and desires, which might be different from our own. It lets us imagine what it's like to be someone else and understand why they do the things they do.
So it's like having a model of someone else's mind in our own heads.
Exactly. And that's crucial for things like feeling empathy, cooperating with others, and navigating social situations.
And how does the aMCC fit into all of this?
Studies have shown that the aMCC lights up when we're doing things that need theory of mind, like trying to figure out what someone else is thinking or feeling.
So the aMCC is like our social strategist,
Yeah.
helping us understand other people and how they might act.
That's a great way to think about it. It's definitely a key player in our social world.
It's been so fascinating. We've talked about emotions and pain, movement and decision-making, and now social stuff. My brain is full.
Mine too. But that's what makes this research so cool. The aMCC is such an amazing part of the brain, and we're only just starting to understand it.
It really makes you wonder what other secrets the aMCC might be hiding.
I know, right? There's still so much to learn.
Well, before we wrap up this episode of Trending Tidbits, let's leave our listeners with something to think about.
Okay, how about this? We know that the aMCC helps us process negative emotions. So, could understanding it better help us find new ways to deal with anxiety and stress in our everyday lives?
I love that. It really highlights how this research could have a big impact on all of us.
And it gets people thinking about how these findings relate to their own lives.
Exactly. Well, that's all the time we have for today's episode of Trending Tidbits on the amazing aMCC. Thanks for listening.
Yeah, we hope you learned something new and interesting. We'll see you next time for another deep dive into the world of brain science.
Until then, keep those aMCCs firing.